Hello everyone. Today's video is the second lesson for this week. Before I start working with the 7.2, the compound angle formulas, I would like to quickly summarize all the equivalent expressions that we talk about in 7.1. From my first video, I have shown the example for the equivalent expressions using the related acute angle. Second type is using the cofunctions identities, and number 3 is involving the different phase shift in the multiple periods in terms of sine and cosine functions. There's also one last type that I did not do an example on it, but I also want you people to make notes of, is that when we are determining the even and odd functions, I just want people to kind of memorize this. They are equivalent, such as the cos of a negative theta is equal to cos theta. The negative theta really means there is a reflections across the y-axis. Okay, so when the cosine functions reflects across the y-axis, you are getting the same functions back. Okay, so that is also the definitions of the even function as well. When we sub in the f of a negative x, we're getting the f of x back. Okay, if you recall that definitions of the even odd functions, if you recall what we talked about, when you sub in f of a negative x, you're getting the f of x back. That means that you're getting the even function. So the cosine function is has the properties of the even functions. Okay, and you can check by graphing the cosine functions for you to see it. Also, when you plug in the sine of a negative x or the negative theta, you are actually getting the negative of the sine theta back. So that's why sine of a negative theta will be the odd function. So this expression is also equivalent. Okay, so the sine of a negative theta is equal to negative the sine theta. Same thing with the tangents. So tangents of a negative theta will also be equal to a negative tangent theta. So that will also satisfy the definitions of the odd functions. So when you put in the negative x, you're getting the negative of the functions back. Okay, so both sine and tangents is part of the odd functions, but the cosine is the is considered to be the even functions. All right. So 7.2. 7.2 is about the compound angles formula, and in this particular sections, there are like 6 altogether. Those are the 6 formulas, but they are equivalent. Okay. Compound angles mean when an angle is created by adding or subtracting 2 or more angles in order to get that. Now, if you're interested in seeing the proof of where those formulas are coming from, on page 395 from your textbook, they have a very good example showing the proof for the formulas. Okay, but of course we're not going to spend times on how to develop those formulas in this section or the rest of the chapter. We're going to use those formula. Okay, so we assume that we're going to take for granted that this are given to us. And same thing, if we are going to have an exam or a final unit test for this unit, those formulas will be given to you. All right, so if you have the handout, so I can just quickly show you how to use those formulas. For example, in example number 1, I want to show how the sine of a 90 is equal to 1. And we all know that if you punch in from the calculator, sine 90 is going to give you 1. It is one of the special angle. But think about using the special angle 45, 30, or 60, we can certainly break the 90 into a 45 plus a 45. So sine 90 is equal to in radian, and as a compound angle, it's a pi over 4 plus a pi over 4. Okay, so 45 plus a 45 will give you the 90. Now, according to the formulas for the sine of a plus the b over here, we know that all you have to do is take the sine of a times cos of b plus the cos of a times sine of a b. So I'm going to do the same thing over here, okay? That when you're taking, well, since a and b, they are the same. So that means by using that formula, all I have to do is take the sine of a 45 times the cos of 45 plus the cos of 45 times the sine of 45, okay? And coming from the special opposite, adjacent, and hypotenuse sine length, we know that the sine of 45, you will get the exact ratio as a 1 over root 2. And same as the cos of a pi over 4, you will get 1 over root 2. So 1 over root 2 times 1 over root 2 plus another 1 over root 2 times another 1 over root 2. Because all sine and cosine 45, you will get the same ratio, 1 over root 2. Okay? So adding the two halves together, you're going to get 1. All right? So this is how I prove that where the sine 90 is coming from using the compound angles formula. Now for the next one, well, the next example is supposed to be example 2. I don't know why the handout has example 3, but I just follow what your handout has. Now, when it comes to the sine of a pi over 12, so you have to quickly make notes of what is this in degrees so that I know how to make that into a compound angles. Okay? So if this one, if you quickly calculate, is 180 divided by 12, you will be getting approximately of a 15 degree. Okay? So think about using the special angles, okay? The 45, 30, and 60. How do we get 15? Well, if you take the 45, pi over 4, subtract the 30, pi over 6. Okay? 45 minus 30 will give you the 15. So here is another compound angles questions that I just created. And if you go back to the formulas here, if you have the sine of a minus the b. So a minus the b is sine a cos b minus the cos a sine b. Okay? So this is what I'm going to do over here. That means I'm going to take a sine of a pi over 4, cos of a pi over 6, but I'm going to minus the cos of a pi over 4 and the sine of a pi over 6. And when I do question like this, I always will have myself this special angles diagram here so that I can look at those. Okay, so this will be the 30, the 60, and so you kind of know what ratio, what sine length that they're going to have. Okay, so I'm going to have this diagram set up here, and I also have one for the 45, and this is a 30 and a 60. So knowing that a sine of a pi over 4, so looking up that, I know that the exact ratio is going to be 1 over root 2 and times a cos of a 30. Cos of a 30 will be here, so it's a root 3 over 2, and then minus a cos of a 45, so I'll be looking at this diagram here, so it will be a 1 over root 2, and then a sine of a 30, so a sine of over 30 is a 1 over 2 over here. Okay, so now after I got all the exact ratio, then I can calculate that into, so this is going to give me a root 3 over a 2 root 2, and then minus a 1 over a 2 root 2. Since I have the same common denominator, so I can now make this into a root 3 minus 1 over a 2 root 2. Now, because the denominator has a radical in it, so when I rationalize everything, when I multiply root 2 over 2, root 2 over root 2, then I will get my final answer as a root 6 minus a root 2 over 2. Oh, sorry. This is going to be 4, because a 2 times a root 2 times root 2 give me a 2. So this will be the final answer here. Okay. The next one, the tangents of 5 points over 12. So again, I'm going to calculate that quickly on my calculator. So I know that 5 points over 12 is approximately equal to 75 degrees. With the 75 degrees, I can make that into a compound angles as a tangent of pi over 4, 45, plus the 30, which is a pi over 6. Okay? And then you will go back and check the formula for the compound formula for the tangents. So now this will be equal to tangents of A plus tangents of B divided by 1 minus the tangent A times the tangent B. So everything basically is you just follow the formula, and then you get the exact ratio. But the only thing that you have to make sure that the compound angle is one of the special ones, because if this is not the special one, then you cannot find the exact ratio, because all of these questions, you have to get the exact values. Okay, that means your answer has to be in exact form. So by following the formula, I'm going to have tangents of pi over 4 and plus a tangents of a pi over 6, and then divided by 1 minus tangents of a pi over 4 and times tangents of a pi over 6. There is a lot of a calculation here, but you just have to make sure that you have the diagram for both the 45 angles, and also you have the diagram for the 30 or the 60 angles, like that. And if you put in all the exact form here, so you will have a 1 tangents of a pi over 4 will be a 1 over 1, so it's a 1. And a tangents of pi over 6 over there, you'll be getting a 1 over a root 3. Okay? I don't like to have a fraction over another fraction, so I'm going to make a division sign here. So I will have a 1 minus tangents of 45 is a 1 times tangents of pi over 6 will be a 1 over a root 3. Okay, by looking at this. So after you make the calculations and everything, and also rationalize the denominator, your final answer has to be equal to 2 plus a root 3. Okay, I'm not going to show you the details, assuming that you will be able to do your algebraic steps correctly by adding this with the common denominator and divided this. Okay, of course you need to simplify what's inside the brackets, but your final answer will come down to be a 2 plus a root 3. Okay, so you can do that. And finally, I would like to show you a various important example here. A cosine of a 17 pi over 12. Okay, so if you follow the same method that I did from before, 17 pi over 12, you will see that this is going to be equal to approximately, well, this is going to be 255. Okay, so an angle of a 255, if you look at from the side here, and you know that this is an angle that is going to be in the quadrant 3. Okay, so this is your 17 pi over 12. So we cannot use a special angle like the 45, 30, or 60 to make it into a compound that will add up to 255. So what we will be doing is we will be using the equivalent expression, but using the related acute angle, because from this diagram, I know that my related acute angle, beta, okay, is going to be equal to the 17 pi over 12 minus the pi. So that will give me a 5 pi over 12. So the related acute angle is 5 pi over 12. But because this is a cosine, so that means this expression here in quadrant 3 is going to be a negative. So that's why I'm giving myself this new expressions to represent a cosine of a 17 pi over 12. And that new expression is going to be equal to minus the cosine of the related acute angle, 5 pi over 12. Because cosine of a 17 pi over 12 is going to be a negative ratio in quadrant 3. Okay, so since we are using that, okay, and that really is the same as the 45. 5 pi over 12, if you quickly calculate that, you know that this is going to be equal to, 5 pi over 12 is a 75 degrees. Okay, so the related acute angle is approximately equal to 75 degrees. So with that, I know that my compound angle for this question is going to be negative cos, but now it's a pi over 4 plus a pi over 6. A 45 plus a 30 will give me the 75. Okay, so this is going to be my compound angles. And from here, I would just follow the formula for the compound angle for cosine when you're adding. So cos of A plus the B is equal to cos A times cos B minus the sine A times the sine B. So I'm going to do that over here now. But what is outside still is the negative, okay, unchanged. But what I have here, for the cos of A plus the B, then I will have a cos of pi over 4 times the cos of a pi over 6, and minus the sine of a pi over 4 times the sine of a pi over 6. Okay? And this will be the cos of A plus the B down here. But what is the negative? You still have to keep the negative signs there, okay, until you are completely done with your work inside. Okay, so cosine of a 45, and again, I'm looking up at the 45 degree diagram. I know that is a 1 over root 2 for cos of 45. And the cosine of 30, I'll be looking at this diagram. So the 30 degrees angles here, cosine is root 3 over 2. Root 3 over 2. And then minus the sine of a 45 is a 1 over root 2. But the sine of pi over 6 is also is 1 over 2. Okay, so this is what I have here. And continue with the calculation. So I should have up here is a root 3 over 2 root 2. And over here is just a 1 over a 2 root 2. Okay, since we have the same denominator, so common denominator, so I have a root 3 minus 1 over 2, root 2. But again, because I need to rationalize the denominator, so I will be getting everything at the end by multiply root 2 over root 2. So I should be getting root 6 minus a root 2 over 4. Okay, then of course we should enclose it with the brackets. Okay, so this is going to be the final answer for the example number 3. And finally, I want you to look at this example number 4b. Is that when you get something that is already in the compound angle formulas, where with the a and the b. So when you have a cos of 3x times cos x minus a sine 3x sine x, so that really will give you the compound angle formula for the cosine when you have the a plus the b. If you look at the formula, so this one actually is the same as a cos of a 3x plus the x. Because when you have a cos of a plus the b, this is how the formula should break down. Okay, as a cos a times cos b minus a sine a times a sine b. So further simplify this, this is going to give you a cos of a 4x. Okay, so this is the kind of answer that you'll be getting.